Okay, let's start solving some application problems involving polynomial and rational inequalities. So the first one I'm going to read to you, it says a toy rocket is shot straight up from a launch pad 1 foot above ground level, with initial speed of 64 feet per second. Part A says write a model to express vertical position S of t seconds after launch. Okay, so here's what we got. We've got a rocket on a platform and it's being shot up in the air. And it's 1 foot, the platform is 1 foot above the ground. Okay? And it's being shot up with an initial speed of, or velocity of 64 feet per second. So the way we would write this is, first of all, they give us the gravitational acceleration or gravitational force with the correct units is going to be 32 feet per second squared. The initial velocity, V naught, is 64 feet per second. The initial height or position of the rocket is going to be 1 foot above ground, which is equal to 1 foot. Okay? And we want our function to be S of t, so in terms of t, it's a function of time. Position is S. So this is going to look, the function they give us is going to be negative 1/2 g t squared plus the initial velocity times t plus the initial position. That is typically the way we write these types of models. And so if we plug everything in, we get negative 1/2 times 32 t squared plus 64t plus 1. And so this would be equal to negative 16 t squared plus 64 t plus 1. And that would be our model for this case, for this particular case. Now, what they want is they want to determine the times when the rocket is above 50 feet above ground. Okay, we can use this model to do that. So what we want is we want to know when is this, what? Above 50. So it's an inequality. But what we're going to do is we're going to set it equal and we're going to solve this polynomial equation as an equation. So it'll be negative 16 t squared plus 64t plus 1 is equal to 50. Now we're going to subtract 50 from both sides. And we're going to get negative 16t plus 64t, or t squared, this should be negative 16t squared plus 64t minus 49 is equal to 0. And now, in this case, this is not going to be easily factorable. Okay? So, we're going to want to use a quadratic formula. So let's solve for t using the quadratic formula. That's going to be t is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now, a is negative 16, b is 64, c is negative 49. So let's plug those values in. So this is going to be equal to negative 64 plus or minus the square root of negative 64, or no, hold on a second, positive 64 squared minus 4 times A, which is negative 16, times C, which is negative 49. All over 2 times negative 16. Okay. Now this is where you're going to use your calculator and simplify things. So we're going to start with the radical. Okay, so we got 64 squared minus 4 times negative 16 times negative 49 . Let me do it this way. Let's do 64 squared minus so we get 960. Okay, so this gives us negative 64 plus or minus the square root of 960 over negative 32. All right. Okay, so 30.98. So we get negative 64 plus or minus 30.98 approximately over negative 32. Okay. So if we simplify this, what do we get? We get two answers. One answer is going to be if we take negative 64, if we take negative 64 plus 30.98 divided by negative 32. Hold on a second, this is not making sense. Come on. Negative 64 plus 30.98 divided by all right, so the first answer we get is 1.03 seconds. 1.03 seconds. And then the other one will give us what? That will give us 2.97 seconds. All right, so now what we've done is we've calculated the 2 times where the rocket is equal to 50 feet above the ground. That's what this equation is. We set this equal to 50, we solved it, and we found the 2 times where the rocket is equal to 50 feet above ground level. Now, if the rocket's going up, right, it's still going up here. And then it's going to come to a peak and it's going to stop and it's going to fall back down to the ground. So as it's falling back down to the ground, it reaches 50 feet again above ground level at 2.97 seconds after launch. So if we're looking at the rocket, it's probably doing something like this, right? It's doing something like this. So here, at this time it's 50, and over here it's at this time it's 50. So any time in between these 2 times, the rocket is above 50 feet. So that means that the times that the rocket is above 50 feet is anywhere between 1.03 seconds and 2.97 seconds. And that is the answer.